Okay, today I'm here to talk a little bit about energy management. When thinking about energy management, everything that comes to mind for me first thing would be turning the lights off. Since I was little, I've always heard that, my dad yelling when I left the room, "You left them on again, turn them off." So I would always run back to that. But today I'm going to talk more about building management systems, and specifically based on air handler units. And within the air handler unit, there's the design, the devices, installation of the devices, the wiring, and then to the end unit as a whole when it's finished. So to start off, I've been in the industry for 25 years, and I've seen a lot of changes with energy management. 25 years ago, most of what I saw in the field was based on pneumatic controls, which weren't part of the electrical industry. As the years went by, more and more of the devices became electrical. So based on that, we're gaining more of the market share from there. The savings with the air handler unit. Savings within that is largely to do with commercial and industrial industries, mainly hospitals, industrial facilities that need air for comfort control of personnel or just the space in turn that it's serving. So moving on to design. Design of an air handler, many different types. So first we're going to look at the fixed components of the air handler itself. So in the fixed components, you have fans, could be one or multiple fans. When there's multiple fans, you would have a supply serving the space that it's typically going to be controlling. When you have a multiple fan system, you can have a return fan in there. With return fans, you will pull in outside air, return air. You can create positive and negative pressures in spaces. Typically, again, in hospitals or industrial facilities where you need to isolate different pressures from rooms so things can't transfer from one space to another. Another part of the design is with fixed units is the dampers. Dampers can limit the flow of air from pulling it from the space or supplying it, exhausting it out of the building. Another fixed component would be coils in the units. Coils can be heating, cooling, or steam. Coils can also be a safety for part of the unit. Yes, what might be a safety for it? Well, with the coils, they could have water flowing through the coils. So they would use steam coils to prevent freezing of the unit if you're pulling in outside air. Filters would be another fixed component in the unit. Filters will collect any dust pulling from the space, going back through so you don't prevent clogging and maintenance issues on coils, and also prevent dust and other debris from blowing back into the space that's being served. So moving on, we'll get into now the devices that will be installed on the unit, different types, mounting procedures. So on the top left, we have a probe type temperature sensor. So with the probe type temperature sensors, they have one fixed point at the end of the probe that senses the temperature that's being in the airflow. So these could be installed in the unit itself or in the ductwork coming in, entering the unit, or on the discharge side serving the space. Typically, the outside, the wiring component portion is going to be mounted external to the unit, not per se inside. Down on the bottom, we have a capillary or an averaging type temp sensor. So with the capillaries, they have multiple points throughout that capillary that have sensing points. So typically, they would be strung, mounted on the outside, the wiring compartment, and strung across the unit back and forth from top to bottom. That way they can sense the complete airflow flowing through the units. Over on the right, space temperature sensors, typical ones you would see on the wall, in your home, in an office. They're going to monitor the temperature, control what's coming out of that unit. On a side note, with them space temp sensors, if people are complaining too much, you can throw one on the wall, they'll adjust it, you'll see jackets come off. They ain't doing a damn thing. They don't know that. Shh. So, we'll move on to another part, actuators, being mounted onto the dampers. Different types of actuators that there are for different sizes of dampers. The larger the damper, the more torque that actuator is going to need to drive the actuator open or close. So dampers, more or less, most of the time, they will stroke one way or the other, either clockwise rotation or counterclockwise. Some may do 180 degrees. With an actuator, you need to understand the stroke of the damper when you're setting them up so that you're not stroking them the wrong way. If they're stroked the wrong way, you can damage the blade of the actuator, you can damage the drive linkages, or you can also burn up the actuator. So they can be set up by flipping the clamp part from one side of the actuator to the other, and there's also some type of actuators you can just turn a switch and they'll rotate one way or the other. Another type of actuator would be mounted on a valve body. The valve bodies are installed in the piping, feeding the coils to the unit, whether it be heating, cooling, or steam on the unit. They're just recently, within, I would say, the past 10 to 12 years, the electric ones have been in service for steam. Steam was generally, in the past, be operated by pneumatic actuators because they weren't affected by temperature changes as much. The new actuators now can handle higher temperatures and larger strokes, which would be the torque, to open and close them valves based on water pressure. Differential pressure transmitters. So a couple things these can be used for. One good thing would be for maintenance. They can monitor the incoming air feeding into the filter bank and also monitor the leaving part of the air. That'll give you a differential pressure which the maintenance facility people can monitor. They can come see, they have a display to see if that filter is getting clogged and whether it would need to be replaced or not. Another reason to put one in would to be monitoring the fan for movement, if the fan is actually running or not. So sensing the air coming from feeding the motor to discharging of the motor. It can also check on damper status, whether the damper is open or closed. So you'll build a pressure up if the damper's closed, or we'll read them as 0 if the damper's open. Humidity and CO2 devices. So in the unit, humidity sensors. Just what it says, it's going to read the humidity flowing through the unit based off of steam humidification coils. These can also be mounted inside the unit, in the discharge duct, different locations, but you should stay a minimum of 8 feet away from that humidifier coil. Within 8 feet, you can oversaturate that sensor. It's going to give you false readings and possibly damage the sensor tip itself. CO2 devices. That'll monitor the carbon dioxide coming through the unit so that you're not discharging a bad air into the space being contained for personnel or not. If you're reading too high of CO2, they can open dampers, pulling in outside air, bringing fresh air into the building, and then the exhausting possible bad air coming back. Moving on to safety devices. So safety devices. First one that would come to mind would be smoke duct detectors. So a smoke duct detector senses air coming back from the space. Whether there would be a fire or something smoldering, it can shut that unit down so it's not cycling smoke back into the space where the occupants would be. These can be either on the return to the unit or the supply. having them on the supply side of the unit will protect against motors catching fire inside the unit or any other devices that could be burning up or smoldering in there, so you're not sending smoke in. Not pertaining to what's being pulled from the occupant space. Another safety device would be a water bug down on the left-hand side. Water bugs are used for a couple different things. Inside a unit with the cooling coil, you're going to have condensation. Condensation will drip down. If the condensation drain line gets clogged up, you'll start flooding out the unit. They're more for protection and safety of the building itself, not pertaining to the occupants that are in the space, not like the smoke duct detectors, more for property damage. They can be mounted inside the air handlers, outside the air handler, anywhere where there would be piping or possible leakage. On the bottom right is just a relay board that safety devices could be wired back to, and off of these relay boards shut down different things, whether it be shutting down the fans, cutting the power to the valves so no more flow goes through that coil. So different ways to shut down what the possible conditions would be. So another safety device would be a freeze stat. So freeze stats, they have a long capillary tube in them. The capillary is filled with a gas. So that gas needs to travel through the capillaries. So like I explained with the temperature device, these things are going to be mounted so that the capillary can run downhill. So back and forth across that coil. That way with the downstream of that capillary, the gas can't get trapped in there. If you're running up and down, a gas can create a gap so that the gas will flow all the way back to the sensing point and trip that. So if there is a trap in there and the gas can't flow, you're still going to bring in cold air into the unit, possibly extreme cold to where you can freeze the coil. Freezing the coil, you won't know possibly right away until it thaws out. So these are another safety device on mainly only installed on units that will be pulling in outside air, anything that will be below 32 degrees to freeze them. Variable frequency drives. And on the right, I also have a starter in the picture there. But talking about the variable frequency drive, it's a way to slow the fans down inside the unit or speed them up, depending on dampers being closed, how much air changes they want to do in the space. You can speed up the amount of air coming, discharging into the occupied space or pulling it out of there. Normally the safety relays will be tied into the VFD drives to shut down the fans based on the smoke or any other type of emergency case involved. Motor starters, mainly what they are is they're going to run that fan at full speed. No way to adjust them up or down. So they're either an on or an off. Safety devices can also be wired into them also, shut them down immediately on a safety issue. So all these devices that we just talked about, they're all going to get wired back to a control panel. So control panels are normally within sight, somewhere located around these air handlers, mainly for maintenance. They can be off in a distance if they needed to be. But the control panels, they're going to have a program installed in them, which is going to monitor all these devices, all these sensors, and make sure that the unit's running properly. They also monitor the space temperature, humidity, to adjust what's going to be done on the discharge side of that unit for the occupant space. That's with the control panels. Different types of control panels. On the one on the left, there's many different points that can be added to that unit. So the more points, the larger the panel is going to be. The one on the right would just be for a basic, smaller unit, not many devices installed. So the architecture for a BMS system. Air handlers would typically be either in the basement or on the rooftop of the building. So with the architecture, you can see there's multiple different things. They can also pick up from chillers to just VAV boxes around the floors, different things that'll monitor and control the building. Based on the architecture, the end user we'll be able to pull a graphic of one particular thing. So this is the air handler we were talking about. The air handler, they'll be able to see moving parts. And the fans are rolling right now. They can see that it's flowing air through the unit. They can see the coil temperatures, the freestat device sensors, anything, filter DPs, what the pressures are, damper locations, whether they're open, closed. Yeah, and once they can see all this, they can also see if there's a problem with any sensor in the unit. Once these sensors show an issue, it can bring up an alarm. Them alarms, they can go into the program, manually override, also send maintenance out to the field to adjust that, find out what the problem is, or replace them. And that's pretty much what I have today on air handlers and with the BMS system and an energy management point. That is something that's kind of lost besides just lighting and different things that are mainly seen throughout what the customer sees out in the field. So.